Irrational, polynomial, inequalities, pre-calculus, pre-college math. So in the previous video, we had problems that looked just like this. And we're going to solve it the same way, except in the previous lecture, there were three roots, but they were all rational. They were not necessarily all whole numbers. We had roots that were like 1/3, 2/5, 1/2, but also along with 5, 7, -2, 0. But they were all rational. This time, as the title kind of suggests, we're going to be working with irrational polynomial roots. And why that is more challenging is because when we do left bound, right bound on our calculator, it cannot give us the exact value of an irrational root. Now, I've mentioned this in the past that when it comes to irrational or imaginary and just complex roots in general, they always come as pairs. They always come as conjugates because of the plus or minus. Like you always get 5 plus or minus rad 3. So you have 5 rad 3 and 5 plus rad 3 and 5 minus rad 3. But there's always two of them. And because this is a cubic function we're working with in this example, we know there are three roots. But if there's three roots, only two can be irrational. Only two can be irrational or complex. And so what that means is there must be one rational root. There must be one rational root. And you have to find that first. You find the rational root, you synthetically divide it out, and then you complete the square with the remaining quadratic to get the irrationals. And so we've seen stuff very similar to this before. And then once we have our three roots, we can figure out if it's positive or negative in those intervals and go from there. So let's type this into our calculator. Let's type in 5x cubed minus 12x squared minus 51x plus 22. And I always start with a zoom 6 and evaluate my graph from there. I'm looking for it to cross 3 times. I don't see it at all. So that's interesting. Oh, what happened to it? That's weird. Let me try it one more time. 5x cubed. Did I hit clear by accident? Probably did. 5x squared minus 51x plus 22. Zoom 6. There it is. Okay. It's always helpful to get a better picture if possible, so I'm going to adjust my window to get a y minimum of, let's start with negative 200 and a y maximum of positive 200 in hopes that that gives me a kind of a curve type of look, and it does. All right, so that's a pretty good picture right there. So I have 1, 2, 3 roots I'm going to test out, and just keep this here as a reference. And it's sometimes good to take a look at your table, see if you have any zeros there. In this case, I do not. So I'm going to have to do second calc 2 and use our friend Toodles to find the roots. Check this one first. Go left bound and then right bound, double enter. That looks like it's going to be irrational to me. So negative 2.464. But I'm going to write it down. Negative 2.464 because I'll use that to check my work later. All right, let me try the next one. Second calc 2. Keep going. Left bound and then the right side bound. 0.4. That is definitely rational. And 0.4, I'd rather have it as a fraction. So let me. Oh, that was the problem. I didn't type it in y equals before. I typed it in that main screen. So 0.4. Math double enter, we'll get 2/5 for you. So that is my rational root right there, 2/5. So x equals 2/5, and that's what I'm going to use for my synthetic division. So 2/5 and 5, negative 12, negative 51, and 22. Bring down this 5 times 2/5. Remember, times 2/5, you could do it in your calculator, but it basically means divided by 5 times 2. Either order. I could times 2 first, then divide 5, or I could divide 5, then times 2. In this case, I think dividing 5 would be easier because 5 divided by 5 is 1, times 2 is 2. These combine to be negative 10. Divided by 5 is negative 2, times 2 is negative 4. Let's see, this will combine to be negative 47, and that one I actually will use my calculator for. oh wait, I messed that up right there, because that itself is negative 56, right? Negative 51 minus 4, negative 55, excuse me. So let me fix that. So you definitely got to be careful with doing the work in your head. Um, Negative 55. But one nice thing is I know this needs to be a 0 because this is a root. So if I'm not getting a 0 here, then I know I messed something up. So divided by 5 is negative 11 times 2 is negative 22, and it does give me that 0, so I'm good there. This translates to 5x squared. It's x squared because it's going to be 1 less than what you started with because you took one of the roots out. Minus 10x minus 55. And I set it equal to 0 and complete the square. Remember, this has to be 0 right here. Now, it's not that I'm setting it equal to this 0. I think sometimes you guys think that. It's because this is a remainder of 0, but it happens to be that I also set it equal to 0. But this is key here. If this is not 0, if you do not get a remainder of 0, then this is not a root, or you mess something up here. But you can't go forward until you find a number that gives you a 0 here. Set the quadratic equal to 0, complete the square. And the first thing I'm going to complete the square is I'm going to divide everything by 5 to turn it into, so let me divide everything by 5, making it x squared minus 2x minus 11 equals 0. I move the constant over to the other side, and then I do my b divided by 2 squared on both sides. That's adding 1 on both sides for this, because 2 divided by 2 is 1, squared is 1. So add 1 on both sides. Factors to x minus 1 squared equals 12. X minus 1 equals plus or minus rad 12. And lastly, I'll write it as x equals 1 plus or minus, and I can simplify rad 12. That'll be 2 rad 3. It's 4 times 3. So that is that, but I also want to include my 2/5. But anyways, so this is, you have to figure out which one is which. This is going to be the 1 minus 2 rad 3, and this is going to be the 1 plus 2 rad 3. And this decimal is what I got for this over here before, so let me check to make sure that that is right, and this will check my completing the square process for me. So 1 minus 2 rad 3, is it that? Yes, it is. So I know my algebra here then is correct. All right, so we continue this problem because it is an inequality. So my roots, my intervals are negative infinity to 1 minus 2 rad 5 to 2/5 to 1 plus 2 rad 5 to positive infinity. And just based on my graph here, I can see it's below, above, below, above. So it's going to be negative, positive, negative, positive. We talked about in class how you could put your calculator on ask and test something in between these, test something in between these, test something in between these, and so on, and you will get these values. The original problem calls us to find the section that is greater than or equal to 0, so that's why I'm going to take my positive intervals. And I have an equal to bar, so I'm looking for brackets. So 1 minus 2 rad 5, comma 2/5, or 1 plus 2 rad 5 to infinity, and we know that always gets a parenthesis. So there's my final answer. All right, that's pretty much it. That's what we'll see here. I think the first step might be the hardest, is finding that initial root and then completing, synthetically dividing it out. Completing the square, this whole thing, we've done that a lot this year, so you should be pretty good at that by now. And again, the nice thing about that is once you get these final completing the square irrational roots, is you could check it with the left bound, right bound, and see if the decimals match out to what you think it is. All right, so we'll practice this more tomorrow. See you.